Hello everyone once again. My name is Dmitry Frolov. I'm Marketing Director at Data Advance. Today here with me is Alexander Prokhorov, Head of Software Development, and Maria Komarova, Marketing Manager. This webinar is dedicated to the new release of pSeven 6.8. So let's start. I will give the word to Alexander Prokhorov, the head of the software development. So Alexander.
Hello everybody. I hope you hear me well. So today I'm going to show you the most of the new features of pSeven 6.8, and I'm not going to do slideware. I will show the software itself. I will show all the features inside the software. So I'm sorry in advance, and if something goes wrong, you know the rule of this live demo. Live demo. It's the first rule of live demo: never do live demo. But anyway, I will try to proceed this way. This slide contains the outline of the features I would like to show. I will probably switch back to it just to check if I mentioned everything I would like. So let's open pSeven 6.8. Here it is. And I will start with a minor but interesting feature. We redesigned the examples gallery. There are a lot of examples inside now. Some of them are well known, which were available in previous versions, but restructured, reworked. All the examples are prepared as a run-ready workflow, so we can just open it, proceed to the run screen, set up parameters, and run. This set of examples. The set of example is intended to be easy to start from. Engineer can pick the proper example, try it, modify it, and so on. There is also a fancy text here. You can see that every example shows what is inside. For instance, this is page viewer and so on. This is, I think, all about example browser. Oh, sorry, I opened this example. I don't need this at the moment. Let me just close this. Okay. So let's start. I have prepared the workflow, the project on which I'm going to show all the features today. Here it is, and let me open the workflow. Yeah, and this workflow is intended to show the features of 6.8 intended to improve the workflow working experience. This is the first group of features I'd like to show today. What do we have here? We have a full factorial DOE block which generates a full factorial sample. We'll use map block to sample some, as I named it, capricious simulation, and you will understand why I named this so. And there are also the calculation of the true function. This is a true function. Part of the work. Hello? Can you hear me? There is something wrong with sound. I will start again about this workflow. I prepared it in advance to illustrate all the features concerning the workflow. What it does, it actually samples some capricious simulations with some full factorial plan. This workflow also generates the sample containing the true values. So this is a simulation sim code simulating some process, and here is the the true answers just to, it will be used later when I will show you new features of predictive modeling toolkit. And the last part of this workflow is just a factorial, this is just a DOE block which generates factorial grid with 1K of points. We'll use it later in the analysis. So, what shall I do? I'd like to start this. Okay, I proceed to the run screen, and you see there is a new fancy counters on the blocks. They were requested multiple times by users. Now it's there. And let me start the workflow. Let me run it. By the way, I can enable annotations here as well. Okay, let's go. And workflow is starting. I see that full factorial DOE generates sample. It made one iteration and it started to sample the model, and oh no, error happened. What is this error about? The model cannot be evaluated in this area. Actually, this model, this capricious model, is not cannot be used in any area of design space. And this is quite often when you have a simulation code which works well in one area, but there are some areas where it just fails. So, and let me go into this composite block. Here it is, and as I mentioned it here, the model fails in some area of design space. And actually, that's okay. This model just don't work there, and it can be applied in those areas, or it even can hang sometimes. We'll see this later. But anyway, what shall I do? I have a simulation code that just fails in some areas. Before that version, we have to add some cascade of blocks checking error codes, results, providing default values, and so on and so forth. It's actually quite boring and may lead to additional mistakes, of course. This time we added this new feature which is named error handling and composite blocks. I can open the configuration. Let's actually do this. I open the configuration of composite block. Here it is. Proceed to options and enable this error handling behavior option. Not to stop the workflow in case of error, but to output default values and the signal port. Check this value here and click OK. I'm ready to run, but oh, I see the issue is red. I need to check what's wrong. Okay, and what I see here is that this my composite block where I just enabled error handling behavior complains that output port F has no value assigned to it, has no default value. And I need to specify this, because if error appears somewhere inside this composite block, this value will be used. So let's do this. Let's go into the configuration again, open ports tab, and set up value for this output port F. Actually, I know that this is a two-dimensional array, vector with two numbers, and I just specify some number here, 1 and 1. Okay. So in case of error, whatever this means, I mean simulation fails, sec faults or whatever, it will catch the error and provide this result. You know, it's familiar with programming languages. Recently, before this version, we could only process error codes, but now we can, I would say, catch exceptions. If something happened inside the composite, we can catch it on the composite level and handle this correctly without stopping the workflow. And in this case, I set up just a real vector with two values, which will be used as a default value in case of error. Click OK. Check issues again. No issues found. That's nice. Save the workflow and run the calculation. Before running that, I'd like to point your attention to this field, the run name. Actually, I've specified the name of... Go ahead. Again, we see that block initializes. Some of them made an iteration, some of them are not. And the C in the log, the same year we saw before, model cannot be evaluated in this area, but it's handled and workflow finished well, without errors. That was the idea. Let's proceed to the Analyze screen to see what we've got. I open the project database and see this simulation data record I specified in the Run screen. Okay, let's create a new report. And what I would like to do is to actually see data. Let's take simulation X and simulation F and drag and drop it here in the working area. Here is the results. And again, new feature of this release. You see these nice colors. Now we highlight the table to easily find extreme values. And of course, red is a maximum and blue is a minimum. That's quite clear. I would like to also copy other outputs of this workflow into this report. This is a factorial grid which will be used later to sample the model we will build. Just a factorial grid with 1K of points. And let's add the test sample with true values, not with simulation, with true values. Here it is. It's about 1,000 points as well. Now I can actually close this project database. I don't need this anymore due to another new feature I will show you right now. Just 1 second. So actually what I'd like to do is to increase the number of points. 100 of points is it's not enough for my demonstration. So I go back to the Run screen, and here is the input specifying the sample size. Let it be about 500 points. Actually I say about because this uses full factorial techniques, and of course it will be power of 2 eventually. But now, oh, not the power of 2, it will be square of some number. No matter. Okay, I changed the input and let's run again. But please note there is a new icon near this simulation name, this record name, which means that if it is enabled, it will simply overwrite previous data in the database. Before that, data are either added to the new record or appended to current one. But in the case when we construct the workflow or we prepare a run-ready solution, we often would like to just overwrite previous runs. So user just change the inputs, run, and get new results. No cluttering in the database. And in this case, this is enabled. I have changed number, I increased the sample size we'd like to generate, and run the workflow again. And there is a surprise waiting for us during this run. I feel it. Let's check what's happening. It runs to see that it is iterating. By the way, and I expect it will do more iteration than before because I increased the sample size and we see that it's about 300 already. By the way, as you can see, those two parts are already finished because this one uses iterative approach and this one uses parallel composite block, another feature which is in the project for a long time already. And it finished almost immediately. It made 1,000 iterations in parallel quite fast. And what I see here, number is not changing. What's wrong? Let me check the output. Let me check the output. Oh, I see that capricious simulations is hanging. And this is another feature of this new release. Sometimes you run the calculation for hours, for days, and somewhere in the end of the process your solver hangs. It happens. Recently we had only before that we had only chance to kill the process and lost, and it probably not lost all the result, but workflow will definitely stop. This time I can just click this button to finish this, to kill this step. Workflow will continue, and the only the only data I will lose is the data of this step, which is actually hanging. So I will lose nothing. Let me click this. Of course, there is a warning. I can say terminate, and see it says that not stopping the workflow because block handling behavior is set to output defaults and signals, and it is trying to terminate the process, the simulation process, which is hanging. It tells cancel job execution by user request. That's right. Let's wait a little bit, and okay, it continues. So some iteration hangs, and we manually interrupted this. We could also do this on this map block. For instance, if it is running long and we just want to say, stop, enough. I'm happy with these 200 iterations you've done. We can click here. During the right hand there is a button as well, and block will gently stop, output the result, and workflow continues. And this is one of the improvements of this release. Okay, let me switch to the analyze screen, and there is the same branch in the project database which named simulation data, but now it contains the new data. So you can check it here. You see there are more than 400 iterations made. Okay, and to immediately see this in report, I just need to click refresh now, and that's how it works in Ready Solutions. You specify some inputs, the override check, you run the workflow, and you get the new results. The only thing you need to do is to run refresh, because we don't want to surprisingly erase the data you saw before, so you need to do this manually. Let's do this. And I see it is updated. There are not 100 but 4 and more 100 points in the report database, and this table is updated as well. Okay, well, let's. What I'd like to do is to recap, just check that I mentioned all the features concerning the workflow execution. I'll switch to PowerPoint. And here it is. Sorry, I need to find the proper slide. Yes. So what I've shown the new fancy examples. I've shown the block startup counters. I've illustrated how to stop a separate block without breaking the workflow execution. I've shown the enhanced error handling, very useful technique for some capricious simulations. And yes, I've illustrated a new option to override and add results to the project database, which with ability to clear report data, it provides a nice way to prepare run-ready workflows. What I need to show is how to create the data in the report. Sorry, how to clear the data in the reports. It's very easy. I can just click here and discard the values. This will remove all the values from the data series, but data series will be left here. So next run it will get the new data. I won't do this right now because I would like to use this data further in the demonstration. So what I'd like to mention also, yes, this is before we proceed to this new cool feature about predictive modeling toolkit named SmartSelection, I would like to highlight another one feature which is intended to run remote calculation on Windows machines. Recently, before this version in 6.7 and others, we could run the remote calculation on Linux machines using SSH. Here it is. Here is the configuration of the block, and we could run simulation calls locally. We could launch the simulation on remote Linux machine with SSH, or even with batch managers such as Slurm-Torque. But when you need to run some simulation on remote Windows machine, it wasn't possible, and now it is. We included a special program named pSeven agent to the distribution, which allows to add your personal machine or Windows server into the calculation process. And you can easily find this program in Start menu in the pSeven 6.8. Let me show this. Yeah, here it is. pSeven 6.8 agent. Let me open it. And here we go. You can configure this, configure authorization, because I don't want to some hackers to use my computer for their needs. I can set up authorization, and this computer can be further used inside the distributed calculation process managed by pSeven. I'm not going to illustrate this at the moment. I better proceed to the features of predictive modeling toolkit. Oh, sorry. Just 1 second. Here it is. So let's go to pSeven again. And I have generated the data, sampling some simulation code. And first I'd like to show you a new nice feature. If you switch to correlations, we see pairwise plots among this data, and we can zoom it, and as you see, colors are here. It was requested multiple times, and here it is. There's a nice feature with zoom and colors and so on. But let's proceed to main features of this release. So what I'd like to do is to build a surrogate model over this simulation data. For this, as before, I will check inputs and outputs and click the build model button. And here is the difference, the big difference. The first thing I need to do is, of course, specify what is input and what is output. And please take a look at this part. And you can see new SmartSelection training models here. What actually SmartSelection means? SmartSelection is a technique which speaks in the language of user, in the language of engineer, and it automatically selects, tries different models, different techniques, and selects the best one which satisfies user requests and data properties. As you know, we have a bunch of approximation algorithms implemented in our tool, but since there is no free lunch, sometimes you need to use the, for instance, Gaussian process approximation, and in other case you'd like to do neural network and so on. And typically, user tries the first one. If it provides better results, it tries the next one, and so on. And this is quite boring, this brute force manual trials and errors, and to remove this, to simplify the user's life, user's work actually, we added this smart selection mode. User just tells what he knows about data, what he'd like to do with the model, and smart selection does all the routines. Let me show how. You don't provide any options, you just provide hints here. I can click this plus button here, and I see, or I can just click somewhere here, and I see there are 3 groups of hints user can provide. First one, speaking about the a priori knowledge of the data. For instance, if I know that my data is linear, I can tell this. And this will help a lot because we will throw away all the nonlinear methods. Or the same for quadratic dependency. I could also know that my data has discontinuities, and I can mention it here. I can say that there are multiple dependent outputs, if I know that. Or I can say that inputs have a tensor structure, such as full factorial or something else. But I can just leave it as this. I can say that I don't know anything about the data, and smart selection will try different sets, try to understand the data by itself and provide the best model. So you don't need to provide this, but if you do, it will save time. Okay, the next part of hints, the requirements to the model. I can require the model to be smooth. For instance, I'd like to use it further in the gradient-based optimization. I can set up requirements to give me a smooth model. I can also require to provide an exact fit model. I can require a model have accuracy evaluation, accuracy prediction. Some technical things, not to store a training sample in the model, store this. For instance, if I want to transfer a model to my subcontractors and I don't want to transfer the data it was based on, I can add this hint and the data won't be included in the resulting model. I can randomize training using just random initialization for each time. And the really cool feature of this release is NaN predictions, not in number predictions. I will come to this a little bit later. The last group of hints in SmartSelection manage the process itself. As a user, I can specify what types of metrics I'm interested in. Let me do this just to show. I added hint about acceptable quality. I can pick the metric, the target metric, and I can specify the acceptable level. And if I added this, you can see this fancy tag here that shows that hint is set. I'm not going to do this right now. Let me just show other hints. Sorry, let's click here. I can limit the training time, and this is a very, very convenient feature. For instance, during this session, I will always limit the training time to seconds, because we don't have enough time to wait while it check a lot of models and pick the better one. And let me set it right now. There are some options. I can leave it by default with no limit. It will try all the techniques. It will take time. I can restrict it by seconds just to, and I'm going to do this right now. There are also options for minutes and hours and nice features overnight. When I go home from work, I can tell it, please find the best model you can during this night. And when I come next morning, I see it provides me with the best model. So at the moment, I will choose seconds, because we don't want to spend your time looking after the training process. Okay. And what else? We could also enable or disable internal validation. Actually, it's a cross-validation, or yes, or set the validation type. We can use internal validation, test set provided from outside, or split this training sample into train and test subsets with a specified ratio. But at the moment I will leave all by defaults. So what have I done? I run the model builder, selected the SmartSelection mode, restrict the training time to seconds, specify that x0 and x1 is an inputs and f1 is output. Sorry, but I better pick f0 for the beginning. Okay, I haven't provided any test source data, but I could. And another feature, I won't close this dialog, I just click a Q button. It will start the training. Yes, it is here. Meanwhile, while it is training, I would like to show you that all this bunch of options which were available in previous versions are actually here. Let me rename this model manual. Oh. Okay. And switch to manual mode. When you switch to manual mode, SmartSelection is completely disabled, and you go back to previous version 6.7. There are a lot of options here. You need to know what you do. There are a lot of techniques here, and for this case I just pick the first one. I know this builds quite fast. I can specify some settings, but I won't. Just click OK, and add this to the training queue as well. By the way, the first training is already finished. And this one is very fast. It finished as well. So what we've done, we've trained the model with the smart selection technique, and as we see, it decided to use tensor approximation because it had found out that the sample has a tensor structure. Let's just, I don't know, let's just compare these two models. It's not fair because actually I didn't give enough time for smart selection to pick the better model. I've restricted to seconds, and on the other hand, I've specified the model GBRT just in case. And let's open the model validator. Two models are here. Let's go to the configuration and specify the test sample. I selected the model, named model, which is built with smart selection. And let me take a test sample, which is provided by the workflow. This is a true function x0, x1, and f0. Okay. And actually, I need to do this for the second model as well, but I will use this shortcut to copy the configuration to all other models. Okay, we can check that this is copied. And okay, let's check a test sample. We see those models are comparable actually, and I said that this comparison is not very good because I restricted smart selection and I pick the model I know works well for this case. But anyway, smart selection model is a little bit better by some metrics. And another new feature of this model validator was the added relative metrics, which were requested multiple times by multiple users, and R2 metrics is here as well. So we see that so actually the model is comparable, and later in this demonstration I will only use smart selection. We've made benchmarking, and we have a conclusive result that smart selection always works better than automatic mod, or the same way. So it's either better, or it either works the same or provides the better results. So it almost never provides worse results. Okay. So you can see on the training sample, GBRT made it selected manually is clearly better, but this is obvious because it uses binary trees. But on the test sample, they are comparable. Well, what shall we do next? I would like to actually plot this model. To do this, I select the model here. I will work with my smart selection model and click the Make Predictions button. It asks me to provide the inputs, and I will use factorial grid we generated in the workflow before. And it asks me to name the prediction data series. I will name it just model. Just keep it as this model. Okay. I click predict. I click predict, yes. And it opens the smart sample viewer with the results. Nice. Let's draw some plots. I will use a 3D surface plot to show the model. Here it is. Quite nice. And by the way, let's also draw the initial sample. I need to highlight this and this. I need to reorder axes, I think, yes. That's good. Let's draw only markers to see the training set. Yes, here it is. So the model is built. We can sample the model right in the analyze screen, and As an announcement, in the next version, we will able to generate design of experiments right here. So you will click the predict, pick the full factorial or LHS or something else DOE technique and provide it right here. It will be in the next version. In this one, we use factorial grid provided by the workflow. So, what else? For instance, let's proceed and try to build a model with the F2. I again select inputs, x0, x1, and this time I select the second output of our simulation and click the build model. Again, I will provide some name, F1, and I will restrict the training time to seconds because I don't want to spend a lot of time during this webinar. Check which is the input and which is the output. By the way, we can add multiple outputs here, but I don't want to do this during this demonstration. Okay, and let's start training. While it's training, I would like to draw this initial data. Not even draw, better. I will check the statistics. And I see that in initial sample F0, there are no nano missing values, but in the F1 there are 24 non-values inside. So obviously this model was impossible to calculate in 24 points. The simulation code fails in 24 points. And as you see, the model is building fine, but actually it throws away non-values. Before training, this is a default behavior. Let me again sample this model and show how it looks. I use again factorial grid, name this, keep it as this. It opens again the sample viewer. We select and let's point the scatter plot, not the surface. We can see the model is created no matter that there are some non-values inside the initial data. To illustrate this, let me draw the plots of initial data. I do the same. This is the initial data, training sample, open 3D plot, rearrange inputs and outputs. Sometimes we need to do this. Okay, and here it is. I've made a mistake. I've drawn the first output and I need a second one. No problem. Let's switch to the second one. Okay, and I see the hole in the center of the training sample. This is the area of non-computability of the model. And unfortunately, our model predicts somewhere here. I don't like this. And in this case, let's train another model. To train another model, I will select this one, click a new button, retrain, which actually builds a new model, but using the initial settings from this one. And say, please enable not a number predictions. We don't use this by default because it could be dangerous in some case, but it is here. And again, I check the inputs, outputs, everything is fine. And I will name this model F1 with NaN. Okay, let's build it. It, of course, will take some time, but not long. Meanwhile, what I expect to see, I actually expect to have a model which behaves well, but keeps the knowledge of this area of uncomputability of the model. That is the goal, and that is the feature, one of the important features of this release, because simulation codes have such areas and we don't want to lose them in the model. It is here. Let's do the same actions as before. I will minimize all the things I don't need. I will keep only the original data, scatter plot, and let's sample this model which predicts nonce. Again, we'll use factorial grid, and as I already said, in the next version You won't need to have this grid, you will just generate it on the fly. And let's predict the values. And let's draw the 3D scatter plot. And here it is. The model had this hole in the center, like the initial sample. And that is great, so we preserved this uncomputability area knowledge in the model. And this is one of important feature of this release as well. So let me check what else I need to show in my slides. Here it is. NAND predictions, I've shown this. Yes. Oh, the thing I need to show is a model smoothing rate. Yes, really. And some usability things. Okay. So we have a model here. It's nice, but sometimes we'd like to make it smoother. I would say it's smooth enough in this particular case, but it's not always the case. Sometimes there is a noise, some oscillations, and I would like to make smooth this model. For this, I select this model in the models list, click a new button here which names create smooth model. It of course asked me for the name of the new model and the smoothing factor. I can specify the single factor for all outputs to all inputs, or I can specify the matrix, which means how smooth I would like to make the outputs relative to some inputs. In this case, I will just tell that this is 0.8. Let it be extremely smooth. It will be extremely smooth, I hope. And create the model. It won't take long, I hope. And here it is. And to show this model again, let's make predictions, factorial grid, predict, see the numbers, and draw the plot. This time we'll use a surface. It looks quite well, quite nice. Let's check the order. Order is fine. And we see that it became smoother, definitely. In general, of course, when you smooth the model, you increase the approximation here, of course, but sometimes you need this. And the good thing is that you can always open this smoothed model and change the smoothing factor to another number, say 0.4. You will get new model. Just 1 second. And let's again sample this and draw. And visualize. Okay. And this time it's not as smooth as before, but definitely smoother than the original data. So this is the new smoothing capabilities in predictive modeling toolkit. And of course, let me recall that once you've got the... by the way, I'm just curious. Let's check which one of these models is better eventually. I will select all of them. No, sorry, I need to select only those because this is another output of the model. Open the model validator. Provide the test sample gathered from proper real answers, x0, x1, and f. Test f1 this case, right? Copy this configuration to all the models in the validator, okay? And switch to test sample. We see that they are comparable, but there is actually, in terms of RMS, the smooth model is better. And that is funny. Probably this simulation code has some noise. Not probably, I'm pretty sure that there is. I added this and then I prepared this presentation. But their main conclusion is that a smooth model sometimes can provide better results. And what concerns relative model, relative years, yes, they are comparable with others and quite good. I think that's it for the predictive modeling toolkit. Let me just briefly go through all the features I presented and check if I forgot something. So, SmartSelection and Model Smoothing Predictive Modeling Toolkit is here. It speaks in the language of user. It listens to user. It provides the model user requires, and it's very, very easy to use. Actually, to get the better results, you need to remove this time limitation, and this will do the work for you. If you just select one technique, then another, then another and another, you anyway will spend this time, and SmartSelection will do this job for you. You just specify what you want from the model, you specify the data, and wait, and you definitely will get the best model possible. Good. What I've shown already, non-predictions is a new feature of this release. Model smoothing again. Model validation usability updates. How to copy test dataset from model to model. I've shown absolute and relative years added in this release. I've shown model training queue. Real-time training log I didn't show, but believe me, it is here. And the last thing I'd like to show you, last but not the least, there is a good model details dialog which shows all the details about the approximation, including training sample statistics about accuracy information. It has accuracy information. It has a complete training log and some technical info. That's it. I think that's it. Yes, that's it about this release. There are some more usability features, but I encourage you to download this version, to read changelog. It is very detailed and very contains all the information you need to understand what happens between those last releases. So, thank you for your attention.
That's all I think for today. Let me once again thank you for coming. Thanks, Alexander, for the presentation of new features. Have a good day. Goodbye.
Dear colleagues, I've looked through the presentation I've made and I have found the awful mistake. I'm sorry for this. If you open model validator I used during the presentation, you see these terrible numbers here in relative predictions and enormous RMS and terrible R2 metrics. And actually everything's fine with predictive modeling toolkit. I just made a mistake selecting test set. Let me fix this. We need to use F1 in here, and I will copy it to all other models. And you see that it is much better. And we see that model created with SmartSelection is much better than manual one. And in terms of absolute years, the same. And in the second model validator, I have made the same mistake. Let me switch to the proper value. I will check F1 and replace it with F0. Copy this configuration to all the models in this validator. And here we are. It is much better, and we see which model is better in this case. And we can also see relative years. It's much better as well. Sorry for this, and I hope you enjoyed the webinar. Have a nice day.